Good afternoon. Today we are going to be in section 1.3, which is about models and applications, aka word problems. So because it was word problems, I made a worksheet that I am screen sharing with you right now, and also there will be a link for it so that you can kind of just work through it. There's not really notes per se for this section. It's just learning how to read the information and do the problems based on what they give you. So I'm going to reference both, and I'll leave it screen shared the entire time so that you can see what the problem is and the information that they give you, and then I'll work the problem on the board so that you can see that. If you print out the worksheet, you can obviously just do the work right on the worksheet. I tried to make it as nice as possible. So the first example we're going to work on is talking about how much salary someone makes based on the amount of education that they have. And so it gives us this nice graph where it shows you how many males and females, or it shows you the male and female comparison of how much they make per year based on their education level. So as you notice, there's an associate's degree, a bachelor's degree, and a master's degree, but those don't have numbers on them because that's the information that we're going to end up finding out through working our problem. So it says the average yearly salary of a man with a bachelor's degree exceeds that of a man with an associate's degree by $25,000. Okay, I'm going to stop right there and I'm going to make some notes on the board because that's the easiest way to do these problems. So it says I have a man with a bachelor's degree. So I'm going to say bachelor's equals a B. B for bachelor's, that's what I'm going to use to denote it. And then it says I have an associate's. So I'm going to let that equal A. And then from the very first sentence, it says that the average yearly salary of a man with a bachelor's degree exceeds that of a man with an associate's degree by $25,000. Exceeds means it's more than, right? So we have a man with a bachelor's degree, and that's the same as a man with an associate's degree plus $25,000. So just from that first sentence, I was able to write an equation. So let's see what the second one says. The average yearly salary of a man with a master's degree. Oh, I haven't labeled that yet. So I'm going to come over here and say master's degree. And I'm going to label that with a capital M, just so it helps me to keep track of what all I'm doing. So a man with a master's degree exceeds that of a man with an associate's degree by $45,000. So we have a master's degree, and that equals the associate plus $45,000. Combined, 3 men with each of these degrees earns $214,000 a year. So if we take a bachelor's and an associate's and a master's degree, that would be $214,000. So let's find the average yearly salary of the men with each of these levels. So we have no idea how much any of these guys make. We just have all these random equations. But here's something I want you to note. We know our bachelor's and our master's based on our associates, right? So they already have A's in common. So let's substitute in. Where there's a B, let's substitute A plus 25,000. Where there's an M, let's substitute in the A plus 45,000. Then our equation will be in terms of A's and numbers, and that's just one variable, one unknown, and we can solve for that. And then we can back solve to find out all of our other information. So B plus A plus M equals 214,000. Well, B was A plus 25,000. And then we have the plus A for right here. Then we had our M, which was A plus 45,000 equals 214,000. Now let's combine our like terms on the left. So we get 3A plus 70,000 equals 214,000. Subtract my 70 over, I get 3A equals 144,000. Divide both sides by 3. And I have A equals, that is a really bad 8, 48,000. So right there, I know that the associates makes $48,000 a year annually. It's pretty good pay for an associate's degree, if I'm just saying. Sorry, slide you down. So now that we know A, we can find out what our bachelor's and our master's makes because they were told to us in terms of A. So we would have 48,000 plus the 25,000 for our bachelor's. And for our master's, we have the 48,000 plus 45,000, and that'll tell us our master's. So our bachelor's is going to make $73,000, and our master's is going to make $93,000. If you wanted to check that, you could add up 48,000, 93,000, and 73,000 and make sure that we get our 214,000 that we were supposed to get. Okay. Move on to the next problem. The next problem is called Modeling Attitudes of Freshmen or College Freshmen. So this one's a little bit wordier, but it's not too much harder mathematically. You just have to understand what it's asking for. And it gives you a nice table. In this table, if we just look at the table before we read the problem, it says life objectives of college freshmen from 1963 to 2013. So in 1969, 42% thought being well off financially was the main life objective. And notice that in 1969, it's the yellow bar, 85% thought that developing a meaningful philosophy of life was important. Notice how those kind of flip-flopped. In 2013, 82% thought that being financially well off was more important than developing a meaningful philosophy of life. Okay, so obviously attitudes have shifted. So researchers have surveyed college freshmen every year since 1969. There's the picture, and we just talked about it. So in particular, freshman class of 2013 was more interested in making money than the freshman class of 1969. In 1969, 42% of first-year college students considered being well off financially essential or very important. For the period from 1969 through 2013, this percentage increased by approximately 0.9 each year. If that trend continues, by what year will all of college freshmen consider being financially well off essential or very important? So, based on the information that they gave us in the graph, we know that in 2013, 82% of incoming freshmen thought being financially well off was the most important thing. So they want us to find out at what point in what year, if the trend continues, would all college freshmen think that way. Right now, 82% think that way in 2013. So at what year will they all think that way? So let's make some notes, because that's the best way to tackle any word problem, is to make notes based on the information that they give you and then write equations based on those notes. Okay. So let's let X equal the number of years since 1969. I mean, right now we could figure out the number of years. However, we don't know how many years it's going to take from 1969 to get to 100%. So we don't know. That's our unknown. We want to find out how many years. We know that it increased, the percentage increases by 0.9 every single year since 1969. That's how many more freshmen believe that being financially well off is the most essential thing. So that means we have 0.9x. It's going up every single year. Okay? But then what was our original starting point? What was the original percentage in 1969 of students? Well, it was 42. We had 42% in 1969. Okay? So we had 42% in 1969. We're going to add 0.9 times every single year, and then we want to get to 100%. So we have 42. We're going to increase by 0.9 times the number of years, but we don't know what the number of years are until we get to 100%, because that is our goal. Now we have an equation with one variable. We solve it just like any other time. We want to isolate our variable. So I'm going to subtract 42 over. So I have 0.9x equals 58. Divide by 0.9, divide by 0.9. And that's not a nice number. That's 64.444 forever and ever. So we say that's approximately 64 years. So it's going to take about 64 years from 1969 in order to get to 100%, where 100% of incoming freshmen think that being financially well off is the most important thing. Well, 64 years is about 2033. I took 1969 and I added 64 years. So by the year 2033, 100, based on the data, if it continued to grow the exact same way it has, by 2033, all incoming freshmen would think that being financially well off is the most important thing. I think this is one of the weirdest ones that we have, because you have to start with the starting, you add the end, how much it's increasing every year to get to our ultimate goal. So the next two examples kind of fit on the same page because they're kind of similar in how we were going to work them. I'll read you, we're going to talk about the toll booth first. So a toll bridge, or the toll to cross a bridge, is $7. Commuters who use the bridge frequently have the option of purchasing a monthly discount pass for $30. With the discount pass, the toll is reduced to $4. So how many bridge crossings per month will the total monthly cost without the discount pass be the same as the total monthly cost with the discount pass? So we want to find out how many crossings do we need to go across this bridge every single month in order for it to actually make sense for us to use the discount way versus just paying every single time we go. So we don't know how many crossings. That's what it says. We need to find out when the crossings are equal. So we're going to let our x equal the number of crossings. That's what we're going to find out. Okay. Now there's two ways that we could cross the bridge. We could cross the bridge by paying the toll. So we have the tollway. And the tollway says that we have to pay $7 every single time we cross the bridge. So it's 7x, because we don't know how many times we're going to cross the bridge, but we know every single time we cross, it's $7. Or there's the monthly way. The monthly way says that we pay $30 up front, and then it's $4 per crossing. Again, we don't know how many times we have to cross, but regardless of how many times we cross that month, if we go the monthly route, it's $4 every time because we've already paid that $30 up front. So it says, how many bridge crossings per month will the total monthly cost without the discount pass be the same as the one with the pass? So we want to know, when are these two things the same? If I say same, hopefully you think of equal. When are those two things equal? So we're going to set them equal. And then we're going to solve for our x in order to determine how many times we have to cross the bridge. So I have 7x equals 30 plus 4. Subtract over my 4. I have 3x equals 30. Divide both sides by 3. And I get x equals 10. So 10 crossings. If I cross the bridge 10 times or less, I don't really need to get the discount pass because it's going to be cheaper to just pay it as we go. If I'm going to cross the bridge 11 times or more, it's going to make more sense for me to get the discount pass because I'm going to save money. Okay. The next example, which hopefully you can still see, it's the second example. Example number 4 is the price reduction in a digital camera. Okay. Your local computer store is having a terrific sale on digital cameras. After a 40% discount or 40% price reduction, you purchase a digital camera for $276. What was the original price of that camera? So we're going to let our x be the original price. We don't know what that is, so that is our unknown. Our original price. We know that we got 40% off. So 40% off, if we write that in mathematical terms, we have to switch our percentage into a decimal, and it's 40% off of what? The original price. So it's 40% of the original price. And our original price we just said is X. Okay? And we know that we spent $276. We spent $276. So we took the original price that we don't know, and then we have to subtract off our discounted price, and we spent $276. Obviously, we're assuming that taxes and everything are rolled in. But that's our equation. We have the original, we subtract how much of a discount we get, which is the 40%, and then that's the total price we paid. So 1x minus 0.4x is the same thing as 0.6x. Divide both sides by the 0.6. And you get x is $460. So the original price of our camera was $460. We took 40% off of that and we bought it for $276. Hopefully that's not too bad. Okay. We're going to scroll down to the next problem. The next problem, I did give you a equation, or an equation, I guess, for simple interest problems. Interest is the principal times the rate times the time, or also you might see it as I equals PRT, where the P is the principal, the R is the rate, and the T is the time. So let me erase this board because we're going to have some notes to take. All right. So we're helping Grandma out today. It says your grandma needs your help. She has $50,000 to invest. So right there, $50,000 to invest. That means our P is $50,000. That's our principal. The amount that you invest is known as the principal. Okay, so the amount you invest is the principal. Part of the money is going to be invested at a non-insured bond at 15% annual interest. The rest is going to be invested at a government insured certificate of deposit paying 7%. Okay. Grandma told you that she requires $6,000 per year in extra income based on these two investments. So how much money should be placed in each investment? Okay, so I gave you a simple interest equation. However, Grandma's not keeping it as simple as we'd hoped. Grandma is going to invest in two different things. So that means she's going to have a certain amount of her principal at one place and a certain amount of principal at the other. So that means we can think about it as we are going to have a total interest, and I'll write total. And the total interest is going to be the interest, or the PRT, at the 15% plus the interest at the 7%. So we have the interest that she's going to make at the 15%. We have the interest she's going to make at the 7%. Now, what's nice is our problem tells us how much total interest she needs every single year. Total interest is $6,000. Grandma wants to make an extra $6,000. So we have $6,000. But now we have these two interest problems over here that we're going to have to figure out. Now it says how much money should be placed in each investment. So we know that total she invests $50,000, but we have no idea how much she invests at 15% and how much she invests at 7%. So we're going to just delegate. And what I mean by that is, let's say that at 15%, she invests X amount of dollars. We don't know how much, so we're going to call it X. Okay, and then she has her 7% one. Well, we could say that she invests Y there, but then we have two unknown things, and that doesn't really help us. What's nice is they told us how much total she invests. She invests $50,000 total. So if we put X of that at 15%, how much is left over for our 7%? Well, we have 50,000 minus however much we put in at 15. So we have 50,000 minus the X. We're going to put X at 15 and we're going to put whatever's left over at 7. Now we have all of the pieces that we need to plug in the rest of our equation. She's going to get $6,000 every single year. So now let's look at our interest for 15%. Well, we have our principal, which we said we're going to let be X. Our rate is 15%, but when you're dealing with percentages, you need to convert those over to decimals. So it's 0.15, and then our T is 1 year. We know it's 1 year because she needs to make that $6,000 every single year. Okay, now let's go to the principal for our 7%. We said was 50,000 minus X. Our rate is, I'm going to have to erase some of that, sorry, is 0.07, and our time was still 1 year. So we have $6,000 equals 0.15x plus, now we take 0.07 times the 50 and times the x, which is 3,500 minus 0.07x. Combine my like terms. 15 take away 7, 0.08x plus 3,500. Subtract our 3,500. 2,500 equals 0.08x. Divide both sides by the 0.808, and that gives me 31,250 equals X. You might think, okay, well, what does that tell me? Well, what did our X stand for? What did we let it stand for? The X is the amount at the 15%. So we're going to invest $31,250 at 15%. So then what do we invest at the 7? Well, we said the 7 was 50,000, take away whatever we invested at 15. So we have 50,000 minus the 3125, and that gives me $18,750 that's invested at the 7%. 31,250 at 15%, 18,750 at 7%. If grandma invests at those rates, she'll make an extra $6,000 each and every year that she has that money invested. Sorry, I'm trying to stay out of the way of the board a little bit. So this one could be a little tricky because you have two different interests that you're combining to get a total interest. So you have to identify that at the beginning of the problem. But it's nice because they gave you how much she's investing overall, and then you're able to come up with the rest of it from there. Okay, I'm going to scroll down on our worksheet. I gave you this nice common formulas for area, perimeter, and volume table. Gave you most of the common shapes and solids that you would be encountering in any type of a word problem situation. I think we only do one here. Yeah, we do. We're just going to do one, and it's going to be a rectangle. Keep it nice and simple. I don't want to lose you guys. Like, I don't pick problems that are overly complicated because I want you to learn the math behind it and not get overwhelmed with other things. So, all right, so example number 6 says, we have the length of an American football field is 200 feet more than the width. If the perimeter of the football field is 1,040 feet, what are its dimensions? So I guess it kind of assumes that you know what shape an American football field is. American football field is a rectangle. So there's our football field. And it says that the length, so we have a length and we have a width. The length is 200 feet more than the width. 200 feet more than the width. So what is the perimeter, and if the perimeter is 1040, what are its dimensions? So it tells us our perimeter is 1,040. We know that we have a width, we have a length. The length is 200 feet more than the width. So what is the perimeter? Well, if you didn't know what perimeter is, you can look up at our nice table over here and go to the rectangles and find the equation for perimeter. Perimeter equals 2 L's plus 2 W's. The perimeter is basically thinking about if you walked around the outside of the football field, how far would you be walking? Well, you walked L, W, L, and W. So you walk 2 L's and 2 W's. Okay, so now we're going to plug in some stuff. We have P equals 2L plus 2W. Well, P, we said, is 1040. We have 2 times our length. Now, what is our length? Well, in the problem, it said 200 feet more than the width. So 200 plus W. That's what our L is. Now, we don't know what our width is because that's our unknown. So we just have plus 2W. So you're going to have to distribute that 2 into the 200 and to the W. So you get 1040 equals 400 plus 2W plus 2W. I'm going to subtract over my 400 and I get 640, and then combine my 2 W's, give me 4W. Divide both sides by 4, and I get 160 equals W. Now, we knew L is 200 plus W. That's 200 plus 160, which equals 360. So we had 360 equals our L. This one is really easy to check. If you take 2 times your width and 2 times your length and you add those together, you'll get the 1040, which is what they told us was the perimeter of our football field. Okay. Got 2 more problems and then we're all done for today. So these are solving formulas with one of its variables. So in your homework and quizzes, it'll give you an equation and it tells you to solve it for one of the variables. All you're doing is isolating that variable. You can't actually solve it because you don't have enough information. Like you can't get 360, but you can get it all isolated so that it is solved for that indicated variable. And I'll show you what I mean. Okay, so for the first one, we're actually using the perimeter equation. We have perimeter equals 2L's plus 2W's. And it says we want to solve it for L. Okay, so what that means, we need to get L all by itself. So what do we need to do to get L by itself? Well, the first thing we need to do is we need to get rid of this 2W. So we're going to subtract that over. So you have P minus 2W equals 2L. Now we need to get L further by itself. So we're going to divide by 2. So you get P minus 2W over 2 equals L. I would probably not leave it that way, but you totally can. You can also write it as 1/2 P minus W equals L. Either of these is correct. All I did was look at the 2 underneath each of those and simplified it. Whichever way it makes more sense to you, you do it that way. So I solved the perimeter equation in terms of my L, in terms of my length, which is all it asked us to do. The other one is asking for A equals P plus PRT. And it wants me to solve for P. So over here, we just started subtracting to isolate our variable. But we can't subtract anything to isolate our variable because our variable is P, and P is in both of the things on the right-hand side. So if it's in both of the things, we can take it out. It's like factoring. It's factoring out something that they have in common. So if I factor out my P, I'm left with 1 plus RT. I took the P out of there, and if I take P out of P, I'm left with 1, because P times 1 is P. P times RT is going to give me my PRT. Now, P is pretty well isolated on the right-hand side. That P is multiplying the 1 plus the RT, so that means I need to divide both sides by the 1 plus the RT. I do that, so that'll go away. And I get A over 1 plus RT equals P. So I solved in terms of P. That's all you're doing on those style of problems. If it asks you to solve a formula for one of the variables, that's all you're doing. You isolate it and simplify it out. That's it for Chapter 1, Section 3. I hope you guys have a good day, and I hope the worksheet helped you.